In this video, we're going to take a look at directional derivatives and the gradient. Let's start by looking at the gradient. We're going to evaluate the gradient of the function x times e to the quantity 2xy power at the point P, 1, 0. So let's start by taking the gradient of our function f. And we'll begin by first taking the partial derivative with respect to x. Notice we have the product rule here. So we'll have 2xy e to the 2xy power. And then add to that when we take the derivative of the x out front, e to the 2xy power. Now take our partial derivative with respect to y, and we have 2x squared e to the 2xy power, and we have our gradient. But they wanted us to evaluate this at the point 1, 0. So substituting in 1 for x, we would have 0 here, and then add 1. And we're substituting 0 in for y. So we would have 2 times 1 over here. And we can simplify that to the vector 1, 2. The second thing we were going to look at in this video was directional derivatives. We're going to look at one at p of 3, 2 for, here's the function. Function f this time is 3x squared plus y cubed. And this directional derivative is going to go in the direction of the vector 5 over 13, 12 over 13. Notice that that is a unit vector. So we won't have to make it into a unit vector. It's already one. Again, we'll find our gradient by taking our partial derivatives with respect to x and with respect to y. And we'll evaluate it at our point, 3, 2. Obtaining 18 and 12. You might want to check my arithmetic. And then finally, finding the directional derivative. Take that latter vector, times it in the direction of the unit vector. Again, we already had a unit vector, so one less step for us to calculate. And then taking our dot product there, we have 90 over 13 plus 144 over 13, and add that up. Our directional derivative at that point is 18. We'll look for any questions that you might have on the discussion board.